states of matter are solid, liquid, gas, and plasma. Plasma is the most common phase of matter in the universe, though not on Earth. Early sailors often noticed plasma as a mysterious blue glow around the pointed mast of their ships. They called this St. Elmo's fire. Stop, you idiot! Plasma is like a gas. It's made up of ions and electrons, though, rather than neutral atoms. In other words, it is made up of charged particles. So you can create plasma by knocking electrons off the atoms in a gas. Plasma thus has so many electrons freely flowing that it becomes a very good conductor of electricity. Lightning is an excellent example of plasma. There are three types of lightning: between clouds, within clouds, and from cloud to ground. Clouds contain tiny little frozen water particles. When air currents within the clouds become so turbulent, they move around these tiny droplets. They bump into each other. The resulting energy causes electrons to separate, leaving the positive ion atoms at the top of the cloud and negative electrons at the bottom. But we know from our previous lecture that opposites attract. The negative particles at the bottom of the cloud begin to attract positive particles from the ground, from trees, from rocks, from houses, from this Donna, from the idiot. These electrons in the cloud start to move in a path towards the ground. Meanwhile, positive charges move up from the ground. This is called an upward leader. When the upward leader meets a stepward leader, a large electric current shoots up into the cloud, and a bolt occurs so quickly that it appears as if lightning travels to the ground, when in fact the opposite is true. This is a discharge of static electricity.
What did we learn from Eric other than he thinks I'm an idiot?
That plasma is lightning is like plasma. Lightning is plasma.
Lightning is plasma, that's correct. And what is plasma?
Plasma is the fourth state.
The fourth state of matter.
Fourth state of matter, which is not found on Earth.
It's on Earth, but you don't see it that often. You see it when you have lightning. You see it, maybe it plasma TVs or ways of using plasma, and we'll see it on a plasma ball. Otherwise, it's the most common form of matter in the universe. When you think about it, all of the stars are made up of plasma. The sun is plasma. Nebulas are plasma, and there's even plasma that roams between solar systems. So plasma is actually extremely common, just not here. But we're going to give an example of plasma right now. Now this is a plasma globe, and there are actually two spheres in here. There's that one in the center, which is actually a Tesla coil, and it's an AC current that will actually throw electrons into the other ball. This other ball contains an inert gas. When they say inert gas, we mean a gas that doesn't react with anything else, which is good because you want to throw electrons in there, you don't want it to explode. So essentially what we're creating is a charged gas, a plasma, which is why they call it plasma balls. And you'll be able to see the stream of electrons when we turn it on. And those electrons, like most things, like water, like a lot of different things, they want to follow the path of least resistance. And what do we know about our bodies? We just demonstrated it. They're not an insulator, that's right. So they're going to want to follow the path of my fingers into me, and where do they go from there? To the ground. Because the ground is the largest supply you have of atoms. They're going to go to the ground. Okay? So, we're going to test that theory out. We're going to test it with this light. If I'm right, and that charge is going into Miss Donna, she should be able to light this bulb up just by touching it, correct? Okay. So, okay, Miss Donna, come here. I want you to put your hand on that bulb.
Flat, flat?
Flat,
Flat.
flat.
All right.
And be careful with these because these contain mercury. And let's see if you can light this up by touching it. It's okay, but not quite what we were literally looking for. Why not? You know what? We need the force. Now, I want you to step up on the stool. Nope, nope. I didn't say kick it. I said step up on it. Okay. Okay. Now, put your hand on the globe. Put your other hand on the light. Whoa, now it's glowing. So who is your teacher? She is your teacher. So we see there really is a force in the universe. Why does it work when you step on the stool? When I step on the ground, it fades out.
Oh,
Okay.
because when you're on the stool, you're not close to the ground, so the electrons can't go to the ground.
What is this stool made out of?
Plastic.
And what is plastic? That's right. You insulated yourself from the ground, so the electrons were no longer going from you into the ground, they're going from you into here. Now, we don't actually have to step on the ground, but we could actually prove it a little bit better just by touching it and running it along, because the electrons are going directly into the bulb. Well, what happens to the electrons when they pass my hand?
It gets dimmer.
Why does it get dimmer?
Because your body's an insulator, conductor,
And
the electron goes to your body and just
that's right. That's exactly right. The electrons are going now at this point into the ground. They're no longer going into light. So whatever point I grab it at, it will stop lighting.